Okay, let's say from the normality test, okay, we found that the science 1 and science 2 are normally distributed. So we want to compare the means for the science score, the pre-test science score and the post-test science score, or the first science score and the second science score. Okay, so what we need to do is go to the analyze, and then this compare means, okay, and then paired sample t-test. Okay, so bring these two variables, science 1 and science 2, to the right. Okay, I want to show also if I start with science 2 and followed with science 1. We can do both, science 1 first or science 2 first. Okay, and then okay. So we will get these results, okay, these tables. Okay, you can see here, see the pair 1 is the science 1 first, and the pair 2 is the science 2 first. You can see the same mean, same number, okay, and then same standard deviation. See, the science 2 is 5.889, and science 2 here also 5.889. And same standard error mean. Okay, and then look at this paired sample correlation. We need to interpret this table. Okay, first we need to look at the two-sided P. Okay, so if it is less than 0.05, it means that there is the significant correlation between the variables. Okay, since there is the significant correlation, then we should rate this correlation, okay, value. Okay, if it is not significant, then no need to read this part. Okay, since there is the significant correlation, so now we read the correlation value. From here, okay, the correlation is between 0 to 1. So if it is near to 1, it means that it has very strong correlation. If it is near to 0, it's like very weak or nearly to no correlation. Okay, so from this analysis, from this result, we can see that it has very strong correlation between science 1 and science 2. Okay, and then look at this PET test. Okay, look at from here. We start from here, this two-sided P, the significant value. P is the significant value. Okay, now the value is less than 0.05. Therefore, there is a significant difference between the mean of science 1 and science 2. Okay, so that is the significant difference. So if there is a treatment, for example, okay, it means that the treatment has effect towards the learning, for example. Okay, so then we need to please be remember that you need to write this T and DF, right? Okay, this is the T value and this is the DF value. Okay, so even when you look at here, for the science 1, the mean become negative while the science 2 is positive. Why is that? Okay, it is because the science 2 is the post-test, while the science 1 is pre-test. Of course, normally in learning, okay, the post-test will be higher than the pre-test. The second test will be higher than the first test because of the treatment, because the treatment has an effect to improve the learning. Okay, that's why if you start with science 1, you will get negative mean. If you start with science 2, you will get positive mean. Both are correct. You can use both. Okay? So if you want to refer to pair 1, your T value will be negative. It's correct. No worries. if you run the pair 2, your t value is positive. It's also correct. So both are correct. Okay, so you need to write this t value and this df value in your interpretation. Okay, since there is a significant difference, you need to interpret the effect size. Okay, remember, refer to the point estimate here. Okay, you can neglect this negative. Okay, because you can see here the pair 1 is negative, the pair 2 is positive. So just neglect this negative. Okay, look at the value. Since it is 2.198, it's much more greater than 0.8. So we can say that, we can interpret that it has very large effect size. Okay, the treatment has very large effect size. Okay, is it clear?